Hello students, Namaste, how are you all? Hope all of you are well. Today we are going to discuss class 9 science chapter number 9. Before explaining about the chapter number 9, I just want to ask you if you have any types of numericals doubt, theoretical doubt, then please drop your doubt into the comment box section of chapter number 8 motion. After completing each and everything about the motion, as we have read about the speed, velocity, distance, displacement, time and graph, velocity and graph, acceleration. After that, I had explained you about the numericals and the equations of motions like v minus u is equal to at, or you can say v minus u is equal to at, or v minus u upon t is equal to a, as I had given you the formula of all the three equations as v is equal to u plus at, or s is equal to ut plus half at square, and v square minus u square is equal to 2as. After completing each and everything, now we will discuss about the chapter number 9, that is force and laws of motion. In this video, I am just going to give you a little bit hint or the flow chart diagram of this chapter, that we must understand each and every topic in detail. But in this video, I will only give you a flow chart diagram. After explaining about this flow chart diagram, then I will move detail in the next video of this chapter. So I hope all of you must understand about each and every topic about this chapter. First of all, in this chapter we are going to study about the force. What is force, as we have studied from 6th or 7th standard, anything push or pull, right? So force is a push or pull, I have written here also. And after then this force I have divided into the three categories. You can see what is the units of force, and after that types of force, factors affects the motion. Now first of all, if I talk about the force, then I just want to inform you force is a push or pull. If I talk about the unit of force, force is a vector quantity. What do you understand by the vector quantity and scalar quantity? As already I had explained you, a physical quantity in which magnitude and direction both are there, then that quantity is called vector quantity. And a physical quantity in which only one thing is there, either their magnitude or their direction, means any one thing. See, generally only magnitude is there, no direction is there, then that physical quantity is known as scalar quantity. So here units of force is a vector quantity and its SI unit is Newton. The CGS unit of force is dyne. Yes, see, there are three types of units also, as we have described about the international system of units in CGS, FPS and KPS. So after going towards that unit, here I just want to tell you, in CGS system, if I talk about, then the unit of force is dyne, and 1 Newton is equal to 1 Newton is equal to 10 to the power 5 dyne. In CGS system, the SI unit of force is dyne, and so you must understand what is the value of 1 Newton. 1 Newton is equal to 10 to the power 5 dyne. Now come towards the types of forces. As I have already written here, the balanced force and unbalanced force, and I hope each and every type of force you may have read in standard 8. There was a chapter about the force in standard 8 also, and all of you have read about this chapter. So let me explain you about the balanced force and unbalanced force. Balanced force, two or more forces acting on an object are said to be balanced force if the net effects produced by all of them about is zero. Just suppose here I am standing, one of my student is pulling this hand and another student is pulling this hand, and I am neither able to move left side or right side. Means what? Whatever the amount of force the right hand side student is pulling, the same amount of force left hand side is pulling. Means what is my net force? My net force is 0. So if I talk about the balanced force, then remember, an object will be said to be a balanced force only and only if the net effect produced by all of them towards the object is 0. Means both the sides it must be balanced, and the net force must be 0. Net force should be 0. That force is called balanced force. And what about the unbalanced force? The net force must not be 0. If the net effect produced by two or more forces of an object is non-zero, then the forces are said to be unbalanced force. Means one side one student is having, see how these things happen. Just suppose one student was pulling by this hand, another was pulling this hand. If one-sided student is very much heavy, he is having a lot of strongness, so he pulled with a great force, right? So as he pulled with a great force means I understand now I am unbalanced. Unbalanced means this side force is less, this side force is greater. So now I am not going to remain stand here, I am going to become unbalanced because the net force is not zero. The net force is not zero. If anyone will ask you what happened in the unbalanced force, the net force is not equal to zero. Got it? About the balanced force and unbalanced force. As I have told you. Now if I talk about the force affects the motion. Force in a certain direction can lead to change in a motion. What are the factors affecting the motions? If I talk about, then what would you like to say? See, first of all, if I ask you when an object is said to be in motion, then you will say that if any force is applied on an object, then only that object will be said that it is in motion. So here the factors affects the motion. Force in a certain direction can lead to change in motion. Means if you apply any type of force in any object in any direction, so that object will be in motion. So after getting the information about the factor or the force affects the motion, not the factors. What affects the motion? If I talk about, then force factors, you can say that force affects the motion. So here I can write force affects the motion. Got it? So after understanding about the force affects the motion, now you have understand there are three types. The Newton had given the three laws of motion, right? First law, second law and third law. You have seen here the Newton's first law of motion. Have you ever heard about the Newton's first law of motion? Newton's first law of motion states that a body continues to remain in a state or rest or if a uniform motion along a straight line unless or until an external unbalanced force acts on it. It is also called the law of inertia. See, what is the meaning of this first law of motion? Means when any object, just suppose this board is there, I close this room for 1000 of years. What do you think? This board will fall down, anything will come here? No, nothing is going to come here until and unless any other force is not applied on it, it is going to remain the same. Similarly, when we throw a ball, why that ball go for sometimes and it stops doing? Because that time as your force is greater than this gravitational force, so that's why the ball is running. As the gravitational force become more than your force, so that ball becomes strong. Got it? So the first law of motion states that any object will remain at rest or in motion until and unless the external force is applied on it. Until or unless the external force is applied on it. Means anything will remain the same until or unless the external unbalanced force. Unbalanced means it will try to stop it. So, and that law is also known as the law of inertia. Now question is, what is inertia? Inertia is that property of a body by virtue of which it opposes any change in its state or rest. Change of motion or a direction. A body which has greater mass has higher inertia. In other words, mass of a body is measure of its inertia. Now question is, as I have told you about the external force, until and unless the external force is not applied on it, so it will not change. It is not going to be changed, either the body is in rest or in motion. So this external force which is applied, that's why this law is also called the law of inertia. The external force which is acting on a body, the external force which is acting or opposing the body to change, either they are in the rest, so they will change in the motion, or if they are in the motion, they will change into the rest. So this changing of the force, a body which has greater mass has higher inertia. Means if the body is very much greater, then they will have lots of inertia, higher inertia, and if the body is not having a greater mass, that body will have little bit inertia. So a body which has greater mass has higher inertia. So mass of a body is measured of its inertia. So mass of a body is measured of its inertia. If any object's mass, the body of the mass is measured with the inertia. Now come second law of motion. What is second law of motion? Newton's second law of motion, it states that external force acting on a body is directly proportional to the change rate of momentum. First of all, you should know about the momentum. The product of mass and velocity. The product of mass and velocity. P is equal to mv. The product of mass and velocity is called momentum. So Newton's second law states that the external force acting on a body is directly proportional to the rate of change of its momentum. If a body of a mass m moving with the velocity v and an external force F change the velocity v in the time t, then the force is directly proportional to change in momentum upon time. Force is directly proportional to change in momentum upon time. So momentum, as I have already told you, moving with the velocity u and final v. So mv minus mu upon t. mv minus mu upon t. Got it? This is the second law of motion. Second law of motion is specially based on momentum, and momentum is the product of mass and velocity of a body. Momentum is a vector quantity and it is denoted by p. If the body has mass m and velocity v, then the momentum p will be mv. P is equal to mv. And if I talk about the second law of motion, so it states that external force acting on a body is directly proportional to the rate of change of movement. See, as in the first law I have told you about, there is no changing until and unless the external force is applied on it. Here, if we apply the external force, after applying the external force on a body, then it will be directly proportional to the change of momentum. It will be directly proportional to the change of momentum. Means if we are really, just suppose that if I am applying a force on a body, then the mass and velocity both will change. So here, that's why I have told you, in the second law of motion, you must know about the momentum. So as the external force acting on a body is directly proportional to the rate of change of momentum. And two things you must know in the Newton's second law, that is momentum and impulse. What is momentum? If I ask you about the momentum, then directly I already told you the product of mass and velocity. Have you heard the word impulse? Impulse is defined as the product of force and time. Impulse is defined as product of force and time. If anybody will ask you what is impulse, so directly you can say force and time. So what is the product of force and time? Impulse is the equal change of momentum. Impulse is the equal change of momentum. Change in momentum is called impulse. So force into time. Now let us talk about the third law of motion. Very important law. We generally say also, when anybody slaps you, you also slap the same person. That is called the third law of motion. Means, for every action there is an equal and opposite reaction. For every action there is an equal and opposite reaction. Action and reaction force act on the different bodies as they can't create equilibrium. Thus, reaction of force is equal to minus action force. Means, as seen, if I apply a force on this wall, so this wall is also applying a force on me. That's why the third law of motion states that every action there is an equal and opposite reaction. Every action there is an equal and opposite reaction. Action and reaction force act on the different bodies. Thus, they can't create equilibrium. So that's why the reaction of force is equal to minus action of force. So this was our third law of motion. They have been divided into the two parts, law of conservation of momentum and action and reaction forces. So this was just a flow chart diagram explanation. More and more things I will explain in the second part of this video, which is just a small concept of this chapter, that what we have to read. That's all for today. I hope that you have understand the concept of this chapter, what we are going to read. That's all for today. Thank you very much. Don't forget to like and subscribe the channel. Share this video with your friends so they can be also benefited. Thank you very much.